Welcome. So first we'll get started with the number system. In this video we will see about natural numbers, what are factors and multiples, what are odd and even numbers, what is called as a prime number and composite number, and what are coprime numbers, and we'll finally look at HCF and LCM. So first let's get started with natural numbers. So natural numbers are nothing but counting numbers. So counting is something very fundamental to the humans. So even in our daily lives, we would want to count the objects. Let's say the number of apples in a given basket, or let's say in the olden days when they were grazing goats, they want to count the number of goats in the shed. So counting is the fundamental to humans. So that's why it is also called as the natural number, with something which is natural. So this includes 1, 2, 3, 4 and so on, and it keeps going, and you can see that it increments by 1 every time. After 1 plus 1 gives 2 plus 1. So it's that way. It is like counting. Okay, this is called as natural numbers. And then we have odd and even numbers. This you can see as, visualize it as something which can be divided into two groups equally. So let's say for example the number 4. So we can divide this into a group of 2, let's say 2 in each group. So this is called as an even number. Even means something which is of equal. So 4 is an even number. Similarly 2 also you can divide it as 1 and 1. On the other hand, if you take 3, how can you can't divide it equally into two groups. So you can either divide it as 2 1 or 1 2, but there is no equal division possible. At least we are assuming that we cannot divide the numbers, or you introduce decimal. We haven't introduced decimals yet. So this 3 is one of the odd number which cannot be divided equally into two parts. So what are the even numbers? So all the even numbers will be divisible by 2. So 2, 4, 6, 8 and so on. Odd numbers are nothing but 1, 3, 5, 7 and so on. So these are the even numbers, and these are the odd numbers. So next we will see what are factors. So factors are numbers which can divide a given number exactly. So let's take for example the number 28. So now when we divide 28 by 7, so it is nothing but 4. The quotient is 4 and the remainder is 0. So when the remainder is 0, we say that the number 7 divides 28 exactly. So that is the meaning of the word exactly. So from this example we can see that 7 divides 28 exactly. So that is the definition of factor. So 7 is a factor of 28. So again if you see 28 divided by 4, so also 7. 7 is the quotient and the remainder will be 0. So it divides it exactly. So 4 is also a factor of 28. So this is the basic concept of factors. Next we'll jump to multiples. So what is multiples? This is just the opposite of whatever is factor. So we said 4 and 7 is a factor of 28. So we can also say 28 is a multiple of 4 and also 28 is a multiple of 7. So it means that if we take this root number and multiply it with some other natural number, then it should give back this number. So then it is called the multiple. This 28 is called the multiple. So if you want to take another example, 10. 10 is a multiple of 2, and it is also a multiple of 5, because 2 into 5 is 10, and also 5 into 2 is 10. So this is the concept of multiples. So now using these factors and multiples, we can define something called as the prime numbers, prime and composite numbers. So first we'll define what are prime numbers. Prime numbers are numbers which has factors of 1 and the number itself. So as we saw example, right, 28 as was having factor of 7, 4, and even 1 is a factor, and then we have what else? So 14 and 28. So it has 1, 2, 3, 4, 5 factors. But what is prime number? Prime number has only 2 factors, which are 1 and the number itself. Let's say the number is n, then it should be 1 and n itself. For example, 2. 2 can be only written as 1 and 1 into 2. So it only has factors 1 and 2. 1 and the number itself. So 2 is a prime number. Then we have 3. So 3 is also again only 1 and 3. So it is also a prime number. If you take 4, so it has factors 1. 2 is also a factor of 4 because 2 divides 4 exactly. And 4 is again a factor of 4. So this is not a prime number. So this way you can check for other numbers also. But one special thing is, what about 1? Is 1 a prime number? No. Because as I said already, prime number has 2 factors. 1 and the number itself. But 1 has only one factor, which is 1 itself. So 1 is not a prime. Okay. Now we'll see about composite numbers. So composite numbers are opposite of prime numbers. So these numbers are not prime numbers. Hence, what should be their property? They have more than 2 factors. So whatever example we gave here, 28 is a composite number. Again, 4 is a composite number. So I'm just writing it here. And there are many other composite numbers. So natural number should either fall into this category or this category. Again, for 1, is it a composite number? No, because again this has only one prime factor. Let's say 1 factor. It has only one and only one factor. So it is neither prime nor composite. So I just now introduced something called as prime factor. You may be wondering what it is. So let me explain it. Again, I'll take the example of the number 28. So we saw that the factors of this number are 1, 2, 4, 7, 14 and 28 itself. Now if you see, 1 is neither prime nor composite, 2 is a prime, 4 is a composite, 7 is a prime, 14 is a composite because it is divisible by 2, and 28 is again composite. So what are the prime factors of 28? Prime factors of 28 are 2 and 7. Correct? So this is what is defined as a prime factors. The factors which are prime numbers is called as the prime factors. So there is also a method called prime factorization. So this is nothing but representing any number as product of primes. Again, going to the example of 28, you can just see 2 divided by 2 we get 14. Again dividing by 2 we get 7. 7 is again prime, so we can't divide it further. So 28 can be represented as 2 into 2 into 7. This is known as prime factorization representation. So we are representing a given number as product of prime numbers. This is called as prime factorization. So next let us go and take a look at what are co-prime numbers. So co-prime. So from the word itself we can see what it means. So take any two numbers. So if they have common factors, as only one, then they are called as co-prime numbers. So before explaining this, I will explain to you what are common factors. So any two numbers, let's take 4 and 10, and we represent it in the form of prime factors. 4 is 2 into 2 and 10 is 2 into 5. Common factors are the factors which are common between any two numbers. It can be also more than two numbers. So here we have 2. Only 2 is common. So we can't map more than 1 2's to the same 2. That is wrong. So for 1 2 we can only map another 2 in the another number. So 2 is a common factor of 4 and 10. Similarly, you take 4 and 28. So 4 is 2 into 2. 28 we already saw, right? 2 into 2 into 7. So now this 2 we can map and this 2 we can map. So 2 into 2 is how much? 4. So 4 is a common factor of 4 and 28. Again 2. 2 is also a common factor. But what are we missing here? We are missing 1. So 1 is a factor of everything, of every number, because every number is divisible by 1. So 1 is also a common factor for every numbers. And here also you get 1 as a common factor. So you can write 1, 2 and 4 are common factors of 4 and 28. Okay, so now coming back. So I said co-prime numbers are 2 or more numbers having common factors as only 1. So 1 and only common factor is 1. I'll give you an example. Take 10 and let's say 21. So 10 is a composite number. 21 is also a composite number. Now let's factorize it. So this is 2 into 5. We'll also add 1 everywhere. So it is easier for us to map. 1 is anyway there. We'll just add it. 1 into 3 into 7. So now if you see, only 1 is the common factor of 10 and 21. But you can observe that 10 and 21 are in in itself composite numbers, but the common factors between them is 1, only 1. So 10 and 21 are co-prime numbers. So this fact can be extended to more than 2 numbers also. So this is the concept of co-prime numbers. So the special property of co-prime numbers is they have one and only common factor as 1. Okay. Next we will see what is HCF. HCF is highest common factor. So we already saw what is a common factor, right? So the factors that are common to two numbers. So what it says, highest common factor. So highest value. So highest among the common factor. Is HCF. We already have an example here. Is 4 and 28. Let me copy paste it here. So we already saw 1, 2 and 4 are common factors of 4 and 28, and which is the highest among them? 4. So 4 is the HCF of 4 and 28. Agreed? So this is the concept of HCF. Now for co-prime number, this is an interesting fact, right? For co-prime numbers, what is the HCF? We saw that co-prime number have only one common factor, which is 1. So the HCF should be 1. Okay. So this HCF can be between more than 2 numbers also. For example, let me take 10, 20 and 40. So 10 is nothing but 1 into 2 into 5. 20 is 1 into 2 into 2 into 5. 40 is 1 into 2 into 2 into 2 into 5. So now we can try to map. 1 is there everywhere. 2 is there everywhere. 5 is also there everywhere. So this 2, there is no corresponding 2 here. So we can't map it. So it should be there in all the 3 numbers. Just because this 2 is there, we cannot map it. So 1 into 2 into 5 HCF of these 3 numbers. What is it? So HCF is equal to 10. So HCF of 10, we can represent it this way. HCF of 10, 20, 40. 10, 20 and 40 is 10. Now let's go to LCM. LCM is least common multiple. We already saw what is a multiple, right? So any number 2. So if we can multiply it with any other number, 14. So 14 is a multiple of 2. If you multiply it with 8, 16. 16 is a multiple of 2 into 4, let's say 8. So 8 is a multiple of 2. This is multiple. So if you take 2 numbers, again I will explain what is common multiple before we go into least common multiple. Take 2 numbers. I will say 5 and 3. So common multiples are 5 and 3. So it should any number you choose, it should be divisible by both 5 and 3. So the first number, let's say 5 itself, if you take, it is divisible by 5. It is a multiple of 5, but it is not a multiple of 3, right? So 15, if you take, it is a multiple of 5 and it is also a multiple of 3. So 15 is a common multiple of 5 and 3. So this passes. Let's take 30. Again 30 is divisible by 5 and it is divisible by 3. So 30 is also a common multiple. Similarly 45, 60, So if you see, if you find 15 and then any multiple of 15 also is a multiple of 3 and 5, correct? So this is the concept of common multiple. So common multiples of 5 and 3 are 15, 30, 45 and so on. Now least common multiple is the least of these values, which is nothing but 15. So 15 is the LCM, least common multiple of 3 and 5. So how do we find this? Again we use prime factorization. So 5 is 1 into 5, 3 is 1 into 3. So now we map same way. So whatever is mapped, right, we only write it as one time, and whatever is unmapped we write it as it is. So this will give you 15 as the LCM. Let's take for two other numbers. Let's say 10 and 20. So 10 is 1 into 2 into 5. 20 is 1 into 2 into 2 into 5. Now we map it. So mapped numbers we write it as only once, 1 into 2 into 5, and unmapped number we multiply it as it is. So this will give it as 20. So 20 is the LCM of 10 and 20. Okay. So there is an interesting property of LCM and HCF. So if you take any two numbers, I will call it A and B. So the product of two numbers is same as the product of HCF of A comma B and LCM of A comma B. So this is true for all natural numbers A and B. So why this is true? Let's see. So A and B, we'll write it in form of prime factorization. Let's say this is Na1 into Na2 and so on, and this is NB1 into NB2 to so on. So A into B will be what? 1 into Na1 into Na2 and so on into 1 into NB1 into NB2 into so on. These are prime numbers. Let's say Na1, NB1 and so on are prime numbers. Now HCF we can find. HCF is whatever the mapping is there. Let's say some of the Na and NB1 are matching. So HCF will be 1 into Na1 into NB1 and whatever is matching. And the LCM, so it is whatever is matching once we have to write 1 into Na1 into NB1, and whatever is remaining, whatever is not mapped, we will write it as once. So in HCF what we are doing, the common factors we are just writing it one time. In LCM the common factors we are writing it one time, and whatever is not common we are putting it as it is. And in the overall itself the common factors are repeating twice. In this the common factors will repeat twice. So we have an HCF into LCM the same thing happening. So that is why this is same as HCF into LCM. This idea may be abstract for you, so I'll give you an example. Okay. So let's take 21, which is 1 into 3 into 7, and 14, which is 1 into 2 into 7. So 21 into 14, what will it have? 1 into 3 into 7 into 1 into 2 into 7. Now HCF will be 1 into 7, right? And the LCM, so whatever is mapped we have to write it once, and whatever is unmapped we have to write it as it is. So now HCF into LCM, let me write it here. So we have 1 into 7 into 1 into 7 into 3 into 2. So you can see whatever is mapped, right, it is occurring twice. Here also it is occurring twice. 7 and 3 and 2 are unmapped. It is occurring once. So this is what I have been trying to say it here. I think now you can better correlate. And again, coming back to co-prime, we said its HCF of the co-prime numbers are 1. So what do you think the LCM should be after this? So LCM should be the product of those two numbers, right? Exactly. Okay. So today we'll finish with this video. Finish it here. And in the next video, we'll see about the divisibility and the remainder theorem. Thank you.